Okay, have you ever been driving, maybe through the countryside, and you see an entire orchard of trees with their trunks painted this bright, stark white, and you just think, what is that all about? Well, let's get into it, because what might look like some weird decoration is actually this amazing piece of science hiding right out in the open.
Seriously, why? It's a question a ton of us have had. And no, this isn't just some random thing farmers do for fun. It's a very deliberate, very smart act of thermal engineering, and it's designed to solve a really specific and honestly a surprisingly dangerous problem for the tree.
All right, so let's just get the common myths out of the way right now. It is not for decoration, it's not some strange folk tradition passed down through the ages, and it definitely has nothing to do with helping cars see them in the dark. Nope. The real reason is so much cooler, and it's this awesome mix of physics and biology.
And that brings us to the first big piece of the puzzle, and to our main villain in this story. See, to get why these trunks are painted, you have to completely forget about the scorching summer sun. The real danger, believe it or not, comes from the winter sun. And there it is, the central paradox. It feels totally backward, doesn't it? I mean, a cold, clear winter day seems pretty harmless. But for a young tree with thin, dark bark, that low-slung sun in the winter sky can be an absolute catastrophe. And it all boils down to one key scientific idea.
And that idea is called albedo. It sounds a little technical, but it's actually super simple. It's just a way to measure how much sunlight a surface reflects versus how much it absorbs. So think about it. A dark surface, like a black t-shirt or, tree bark, it has a low albedo. It just soaks up a ton of heat. A white surface? Totally the opposite. High albedo. It reflects all that energy away.
And this comparison here just lays it all out. That dark tree bark, it's like what scientists call a black body. It's an energy sponge, absorbing up to 90% of the sunlight that hits it. But the white paint? It totally flips the script. It becomes a reflective shield.
Okay, now this is where it gets wild. Look at the result of all of that absorption. You've got a freezing day, right? The air temperature is -5 degrees Celsius, that's 23 Fahrenheit. But the side of that dark tree trunk that's getting hit by the sun, it can warm up to a balmy 20 degrees Celsius, that's 68 degrees. That is a 25-degree swing. This massive temperature gap is the danger zone.
So what in the world happens when one side of a tree thinks it's a pleasant spring afternoon while the rest of it is still in a deep freeze? Well, this is where the biology gets a little bit brutal, and we get to see how the bark can quite literally be damaged from the inside out.
And to really get the damage, you have to meet our victim, the vascular cambium. This is this super thin, super delicate layer of tissue sitting just underneath the bark. Think of it as the tree's engine of growth, its entire circulatory system. It is absolutely vital. If this layer dies, the tree is in huge trouble. So all of this creates something called the deacclimation trap. Here's how it works. Step 1, the winter sun heats up the bark. Step 2, this warmth completely fools the cambium layer. It wakes up from its winter sleep thinking, hey, it's spring, and its cells start pulling in water, getting ready to grow. But then, step 3, the sun sets, and that bark temperature just plummets, right back down below freezing. And that leads to the final catastrophic step. All that water that just rushed into the cells freezes, it expands, and it bursts the cell walls.
And this isn't a one-time thing. It happens over and over on these cold, sunny winter days, causing massive damage at a cellular level. And eventually, the bark just can't take it. It cracks, it splits open, and it starts to peel away. The name for this condition is sunscald, or sometimes people call it southwest injury, because it almost always happens on the southwest-facing side of the trunk, which gets hit with the most intense afternoon sun.
So how do you stop a tree from basically boiling and then flash freezing itself to death? Well, you give it a shield. An elegant, low-tech, and incredibly effective solution that comes right out of a paint bucket.
The fix is just white paint. That's it. Specifically, it's a 50-50 mix of regular old white interior latex paint and water. By painting that trunk white, you are cranking its albedo way up. You're keeping the bark temperature much, much closer to the cold air around it, and you prevent that deadly false wake-up call from ever happening.
But listen, you can't just use any old can of paint you have lying around. The choice here is absolutely critical. Interior latex paint is water-based, it's breathable. It allows the tree to do its thing, to perform gas exchange right through the bark. Oil-based paint, on the other hand, that would be a complete disaster. It would literally suffocate the tree, clogging up all its pores and killing the very tissue you're trying to protect.
But wait, the story gets even better. Because in this fantastic little plot twist, that white paint isn't just acting as sunscreen for the tree.
it has some other brilliant secondary benefits that make it an even smarter tool for anyone taking care of trees.
For one thing, that smooth white surface is a really terrible place for wood-boring insects to try and lay their eggs. They much prefer dark, warm cracks and crevices in the bark. And second, against that clean, white background, it becomes incredibly easy for a farmer to spot any signs of trouble, like the telltale waste from a boring insect, or the little bit of sap bleeding that signals an infection.
So really, the next time you see a field of those white-painted trees, you're not just looking at a pretty uniform pattern. As the source material puts it so perfectly, you are seeing a passive cooling system in action. It's a simple, brilliant piece of engineering designed to help a tree survive its most dangerous season. And that just makes you wonder, doesn't it? What other amazing solutions, what other bits of natural engineering are hiding all around us, just waiting for us to notice?